B2, this question is about quantum aspects of the electron. It says the graph shows a variation with distance x of the wave function of an electron at a particular instance of time. The electron is confined within a region of length 2 times 10 to the negative 10 meters. So state what is meant by the wave function of the electron. Well, the wave function squared, it's actually squared, is proportional to the probability of finding an electron at a certain place there, or at a certain point. Then it says use the data from the graph to estimate for this electron its momentum. So to do that, we're going to be using this formula over here, that your momentum is equal to h over lambda. That's the Broglie's hypothesis. Now we need to work out the wavelength. Now we can see here that we have this wave function, and each of these would be the wavelength. So the total wavelength is the total for 6 wavelengths. If you go count here, you'll see that there's 6 of these. There's 1, 2, 3, 4, 5, and 6. So the wavelength is going to equal to 2 times 10 to the negative 10 divided by 6. And when we do that, we get 3.3 times 10 to the negative 11 meters. Now we can then put that into this formula over here, that your momentum is equal to h, which is Planck's constant, 6.63 times 10 to the negative 34, and we're going to divide that by 3.3 times 10 to the negative 11, and you will get there 2.0 times 10 to the negative 23 and 10 to the negative 23. Now the momentum you can write as, obviously it can be written as a kilogram meters per second to the negative 1, or you can write it as a Newton second, depending on how you want to write it. So that's that question. And then question 2, the uncertainty in its momentum. Now the uncertainty is given by this, which is Heisenberg's uncertainty principle. Now we have here our change in x, change in p, our uncertainty in our position, our uncertainty in our momentum must be greater than or equal to, so this is the minimum value, h over 4 pi. So our uncertainty in our momentum is going to be greater than or equal to 6.63 times 10 to the negative 34 divided by 4 pi times our change of x now, or our uncertainty in x. Now we can see here that it says here it is confined within the region of 2 times 10 to the negative 10. So there's different ways of doing it. If the electron was for instance somewhere in this region, it could be over there. So this actual amount is your uncertainty in x. So it's going to be times 2 times 10 to the negative 10. It was accepted that you write, instead of 2, you do sort of the halfway. So there would be uncertainty in that way and uncertainty of that way. So if you put 1 times 10 to the negative 10, it was actually accepted. But this would give your maximum uncertainty, which is always the best way to go. And when you calculate that, you get 2.6, works out to be 2.6 times 10 to the negative 25 Newton seconds. So your momentum would be that plus minus your uncertainty in the momentum.